Hi, welcome to another episode of I Can Alteryx That with Coaches Alex and John. I'm John. Today, we're going to cover Alteryx Weekly Challenge number 221, Avocado Consumption. Let's get started. Alright, so in this week's challenge, our goal is to look at this data on avocado consumption. So we've got, for each region, we've got conventional and organic avocados between January 2015 and March 2018. We've got the total volume, and then we've got these things called PLU codes, which are 4-digit codes that classify different, varieties or types or something or other. So we got 4046, 4225, and 4770. And our goal is to determine for each type, conventional and organic, what region had the largest percentage growth between January 2015 and March of 2018. So you can see for the total volume, what they've called TV, we've got Albany and Boston. For 4046, we've got Pittsburgh and Syracuse, and so on. So, looking at the initial data again, the solution that I've come up with is certainly not the most elegant solution, but it's pretty simple. It's a lot easier to understand than things that might be more efficient. So the first thing that I went ahead and did is grab the filter tool, and I'm going to make a filter that says, it's going to be a custom filter, so in parentheses, year equals 2015, and month equals January, or year equals 2018, and month equals 3 for March. Let's get this output out of the way. And you can see that when I do that we're now only going to have records for the very first month and the very last month of the data set. So for Albany, we have 2 records for conventional. Albany, we have 2 records for organic, and so on. So each region is going to be listed 4 times. So the next thing that I want to do, and we're just going to copy and paste this for total volume, 4046, 4225, and 4770, is let's go ahead and grab a crosstab tool. From the crosstab, we're going to group by region and type. Our column headers, we can just use the year. Well, I don't care about the month because I know that the year is either 2015 or 2018. So it doesn't matter what the months are because I already filtered it to only have my beginning and my end period. The values for the new columns on this one will be sum total volume, and we'll make sure we aggregate it by summing. And when we run this, you can see that we now have the total volume sum for our beginning and our end periods for each conventional and organic. So now we can go ahead and actually calculate the percentage change. So we can call this, to make things simpler, we'll just call it percent change. And this will simply be 2018 minus 2015 divided by 2015. And then just to format it like they have in the output. As you can see here in the output, they have, for example, 213.79. And you can see in our data preview, we have 2.1379. So let's go ahead and multiply this by 100. And we're going to round it to the nearest 100th. And there we go. There's our 213.79. Make that a double. And you can see when you go ahead and run this that we have all of our percent change values. Nice and neat. So the next thing that I want to do is make sure that our sort order is correct. So we're going to sort by type in ascending order and by percent change in descending order. And the reason that I'm doing this is that now by sorting by type, because I want the type with the most percent change for each region, or for each thing. So now I can use the sample tool and just grab the first record from the type. We're grouping by type, so we get the first record in conventional and the first record in organic. So again, first n, where n is 1, group by type. And you can see when I do that, And we're now only going to have two records, Albany and Boston. And looking back up here, that's precisely what we have. So the last thing that I'm going to do here, actually, you know what? I don't even need, I'll do that in a later step. So let's just go ahead and grab all that, copy and paste. Again, this is not elegant at all, but it's simple. It was the first thing that came to my mind. You know, if I was doing this for like a client project or for work, I would definitely come up with a more dynamic solution. And I've already seen other solutions on this that have been posted that are more dynamic. So if there were additional PLU codes, they would be pulled in automatically, whereas my solution, they would not. But you know what? That's not really important here. I was just trying to come up with a solution as fast as I possibly could. And I think I accomplished that goal. So I'm just going through here, and for each of the crosstabs changing whatever's being summed, and let's just make sure that those are all accurate. And forward, okay. So what I'm going to do now, let's just go ahead and run this, get rid of that little error. So you see we have the exact same data set in every one except we're summing up different PLU codes. So now let's just go ahead and grab a join multiple. Just join everything together all at once. We don't get to use the join multiple tool all that frequently. So we're going to join everything on the type fields. So let's go look at the output and make sure that we format this correctly. So we've got type. Okay, so we just got the type at the beginning. So then we're going to deselect all of the years. So 2015, 2018, those are all going to be deselected. You have type. So in the first case, region is just called TV, and the percent change is TV percent. We don't need that other type, so this one will be 4046. 46%. We don't need this, oh, pardon me, this region is now, what was that, 4025, I think. We don't need that type. This will be 4025%. Oops. This will be 4070 and 4070%. All right, let's go ahead and run this. Hopefully we got everything formatted correctly there. All right, look at that. Oh, looks like I misnamed some of those. Those are 4025 and 4070. I think I typed in. What? Oh, sorry, 4770 and 4225. I mislabeled them. Not that it really matters at this point, but if you're going to do something, might as well do it right. All right, and when I run this, we should have a nice solution that matches the given solution perfectly. I don't know, 4225. I just can't seem to get that one right. All right, now we got it. But in any case, yeah, again, not the most elegant solution. It's not dynamic, but you know, whatever. We got the right answer, and it was simple and easy to understand. So in any case, there's my solution to weekly challenge number 221. Thanks for watching. As always, thanks for watching the video. Don't forget to subscribe to the Data Coach channel for more awesome lessons on Alteryx and all things data analytics and visualization. Follow Data Coach on Twitter at AskTessellation and follow me personally at jemory_dataviz. Thanks again.